Okay, I want to welcome you to this worksheet. This is writing half reactions from balanced redox reactions. A couple of things to remember. The first thing to note is that we need to be able to distinguish between oxidation and reduction. We're going to use a couple of mnemonics here. The first one is Leo says Ger. All right? Losing electrons is oxidation, and gaining electrons is reduction. Another way we can remember this is oil rig. It tells us essentially the same thing. Oxidation is losing, reduction is gaining, just like that. So what we want to take a look at is a couple of different reactions from redox reactions from Zumdahl. Remember that when we say redox, what we really mean is we're talking about the transfer of electrons, right? We're talking about the movement of electrons from one chemical species to another. So let's take a look at this first one here. Let's take a look at this problem from Zumdahl, page 842. This is part A. It has two hydrogen ions. This is an aqueous solution together with zinc, which is a solid, becoming zinc ion and H2. So we want to identify the oxidation and the reduction. So here we see zinc going from the solid form to zinc 2+. So that's obviously an oxidation, since the oxidation number is rising. Remember, if the oxidation number goes down, that's a reduction. If the oxidation number goes up, that's an oxidation. So in this case, it's clearly an oxidation, right? An oxidation. So what's being reduced? Because if something's being oxidized, something else has to be reduced. Well, in this case, it's hydrogen. We have 2H plus 2 electrons in this case yields H2 on the other side. So we're going, in this case, from H plus to H2. The oxidation number is going down, so this again would be a reduction, okay? So there's our oxidation and reduction. Notice that in this case we have 2 electrons on the left-hand side, or from the zinc, being released, and those 2 electrons that are being released are being taken up by the hydrogen. So again, we see that this is an oxidation-reduction reaction, with the oxidation half reaction being the first part and the reduction half reaction being the second part of that equation. Okay? So that's part A. Let's take a look at the next one. Let's look at B. By the way, all of these problems are from Zumdahl, so if you want to take a closer look at the context that they were brought in from, go to the page numbers that I've listed there. In this case, it's page 843. So here we have zinc solid combining with copper ion to give us zinc ion and copper solid. So again, how do we divide that into oxidation reduction? Well, remember that the reduction is the one that lowers the oxidation number. The oxidation is the one that rises in oxidation number. And by the way, I suggest that you start with the reduction because that's in our brains easier to wrap our minds around. In this case, we went from +2 to 0 to copper solid. So that's clearly a reduction, right? So that's the first one we'll write. Also, note in the reductions, the electrons shown are always on the right-hand side, right? They're on the right-hand side, or excuse me, the left-hand side. They're on the left-hand side because they're being taken up by the Cu2+. So for every reduction, we have to have an oxidation. In this case, the oxidation is going to be zinc. So zinc then is going from zinc with an oxidation number of 0 to an oxidation number of +2, right? So that then would be the oxidation that we're looking for. So we've divided then that reaction into oxidation and reduction half reactions. So let's go to the next one. So in the next problem we've got, this is on page 845 if you're following this in the book. On page 845 we've got iron 3+ plus copper solid going to Cu2+, that's aqueous, plus Fe2+. All right. So what's being reduced? Let's start there. Again, remember, it's easier to start with the reduction because we have an intuitive feel for what's going on when we're going from Fe3+ to Fe2+. Clearly, the oxidation number is going down. That's a reduction. So that's the reduction half reaction for this problem. Fe3+ is gaining an electron, right? Reduction is gaining. It's gaining an electron to become Fe2+. Copper, on the other hand, is going from 0 to +2. So it's gaining 2 electrons. By the way, these half reactions aren't balanced. So we'll talk in another video about how to balance those half reactions. But for right now, I think we've got the general idea. Reduction is gaining electrons. That's what's happening here. Oxidation is losing electrons. So in this case, we're losing electrons here. All right, very good. Let's go to the next one. We're on page 833 to 834 now. This time we've got beryllium 4 plus becoming beryllium 3 plus. Just like that. That's clearly a reduction, right? So that's the reduction part of our half reaction. And then we've got tin going from tin plus 2 to tin plus 4. That is an oxidation. That's our oxidation right there. All right. And finally, we go to page 839 to 840. This is a more complicated problem. We've got 8H plus MnO4 minus plus 5Fe2 plus going to Mn plus 2 plus 5F3 plus 4 water. All right, so what's being oxidized and what is being reduced? Well, in this case, clearly we're going from the manganese, we're going from this to this. That's our reduction. That's the reduction. And for every reduction, there must be an oxidation. Iron is going from plus 2 to plus 3. So that's our reduction there. All right, that's our reduction there. So you'll find, for example, that in this case, what we're going to need to do is multiply this half reaction by 5 because of the fact that I've got 5 electrons on this side and 5 electrons on that side. But that's a matter for another video. I just want you to, in this particular worksheet, be able to calculate or determine how to get half reactions from balanced redox reactions. That'll do it for now. I'll see you on the next one.